So I'm taking question number 30 of the book Pathfinder, chapter Kinematics, section Check Your Understanding. To cross a river of width B, a boatman steers his boat always aiming towards a point that is directly opposite to the starting point. Velocity of the boat relative to the river current is given as VBW, and the river current velocity is VW. 1.5 meter per second everywhere. Determine time which the boat will take to cross the river. So this is the question. See, this is a river bank. A boatman starts from A and he wants to reach just opposite to A, that is a point B. P is just opposite to A. And this distance, this is the river width which is given as B in the question. The river flows with some velocity. I have taken as u for convenience. Though in question it's given as vb, I am taking as u. Okay. Now this is the path of boatman. An arbitrary path I've just drawn like this. So the boat is being steered towards the destination point B at all times. So boat will have these two velocities as seen from ground, the velocity of water as well as the velocity of steering of the boat with respect to water. So whatever be the resultant will be somewhere in between. So at this point, the boat will be moving in this direction. So it will be a curved path. Now we have to find the time in which the boatman will reach to B. Okay, so this is the question. Suppose the boatman at this point is at a separation S from the destination point B. The rate with which S is changing at this instant, it is decreasing with the rate VBW. VBW is the velocity in this direction. So if the boatman goes in this direction, S will decrease with this rate. So since it will decrease, I have put a minus sign and with this rate VBW. And the component of u in this direction is u cos theta. If the boat happens to move in this direction, then S will increase, therefore plus sign, increase with the rate u cos theta. So the overall rate of change of S at this point is a decrease of VBW, and the rate will increase with this value u cos theta. Okay, so this is mathematical expression for rate of change of separation at this instant. Cross multiply with dt, integrate every term, put the limits. So initial separation is B when the boat started from A. So initially it was separated by a distance B. Initially time was 0. So lower limits corresponds to like this. And finally S will become 0 when the boatman reaches to B. And finally let the time be T. And if you solve this, so this term will solve to minus B. The second term will solve to minus VBWT. This last term u being constant can be taken out. And now we cannot solve this term because there are two variables, theta and t. So we can integrate only when there is one variable. So somehow we have to solve this integration by using some trick. Let's see how we can solve this expression. To solve this, okay, I'm again taking the rate of change of x. So this distance is x. So x is increased with the rate u, obviously, and x will decrease with the component of VBW in this direction. So that is VBW cos theta. So this is the rate with which x is changing. Multiply by dt, integrate every term. Initially x is 0, x will increase up to some point, and then x will decrease to 0 again. So this distance is x. So x is increasing and then again decreasing. So the limits of x are 0 and 0. This term will solve to ut, VBW being constant taken out, and this is integration of cos theta dt. So we can solve this integration of cos theta dt from here very easily, and now we can put the value of cos theta dt integral into this expression, and we can solve for time.